Good afternoon. I would like to tell you about the current state of affairs. Actually, in Red Hat, Enterprise Linux 8, and Fedora 3031 as to identification and users management. It's an overview of the state of authentication and identity management in Red Hat Enterprise Linux 8 and Fedora 3031. We were engaged in transforming this all in a more contemporary way, so to put it. But first of all, I would like to celebrate a jubilee together with you. This year, it's exactly 40 years of POSIX API service for user groups. It's getpwuid, now getpwuid, common version 780NT. For the first time, they appeared at AT&T Unix version 7 in 1979. It's quite interesting because here is the example of a software interface which exists without external changes. It has been existing just like that, without external changes for 40 years, and its semantics did not turn around a lot over those 40 years. Very stable and sustainable. And thanks to such kind of a stability, POSIX-compatible systems are ruling this world. Having said that, I can say that it's not just only about this jubilee. Last year it was 25th anniversary, I might say, of network service switch, which enabled us to store user information differently and to put them into a system without changing the upper API. In the upcoming year, there will be another jubilee, 25 years since a similar API appeared for user authentication, authorization, and sign-on control. This API did not change in POSIX-compatible systems and Linux and others, which it's just pluggable authentication modules. They are the same. They are very diverse, but it's the same API. And if we look behind the facade, so to put it, all those interfaces, it's network protocols which have been around since long way back when it comes to authentication. 1984, SNB protocol, Kerberos, 1988, 1993, we use Kerber 5 as well. LDAP, the response to sophisticated structured work with the over-bureaucratized bureaucracy directory in 1995, work with smart cards, then PKCS11, 1994, and then outside POSIX system, everything was identified in Microsoft Windows Active Directory of 1998. So we can see that not only those APIs, but all those protocols, they all were born in the recent APIs from that, actually, which was created in 1990s. This is a real picture, the event which happens every year in Finnish towns. The graduates of high school are clad in bizarre outfits, and they are riding around with those posters in Helsinki. Such a ride takes about 2 hours because there are lots of those students, lots of those trucks. They ride around, throw candies and cookies. People are picking them up. Those characters display the diversity of different things we have to deal in real life at the systemic level. On the other hand, having such a standard API for 40 plus years, we have got lots of diverse realizations and implementations. Here we can see the variety of those implementations. Here are only some of them which are relevant, mindful of our conversations. They work with LTOP, servers, smart cards in Windows, and so on. And there are lots of other specific modules from different vendors so that this hardware could be used for authentication, authorization, and so on. They are vendor-specific PM. And such a diversity of implementations entails complexity of management and operation. Here is very typical system Linux on distributive. Lots of modules in this typical Linux distribution, different modules related to different user groups, shown by yellowish orange color, and authentications and authorizations, PAM interface, they are shown by greenish color. That's very typical situation. In both places we have got modules stacked. Modules can layer on top of each other, and user group search could be done in one source, in another source. Since 2017, let's see, the information about different user groups, how they could be united from different sources together, which had been the case before. And on the other hand, at PAM level, PAM module levels, we see the setups of that, which is not quite commonplace as well. And bottom line, all this complexity is also about the fact that all those tunings and setups are local. On a specific machine, you don't have just to describe those module stacks or to use those which are within the distribution and they are already tuned as set up. But all of them require their own parameters. Let's see, if you retrieve data from LDAP, you should refer to which LDAP server you get, where exactly in its tree those users are sitting, which should be the way we should get to this service, to this tree, so that to retrieve all that information can be information about group members. It can only be retrieved after authentication, not directly otherwise, not otherwise. So all this information about how to retrieve the information should be present here as well. And also there is one unique thing here, that all those modules are uploaded in any app which tries to retrieve all those functions, getpwnam or PAM function, and this entire stack modules are getting uploaded one after another, and the information from them, information about different setups, is uploaded into your application. It's not so safe because in any of your app, the password is uploaded in order to join up with LDAP. Any application whatsoever can steal and take away this information. So we reformed this in a way. We revised the approaches, and the general direction was that those modules which are uploaded in any application, they should be very small, compact, and straightforward, and they would communicate to a daemon which will be sitting in the same machine doing all the work. We isolated everything just like that, and then there appeared a wide number of different requirements which were not there before. It's amazing, but it's a fact. In all the POSIX and API, it's not possible. There is a user we have, and what is user's email address by a POST API? It's not possible to do that. There is no such an API at all. Over the recent span of years, like 20 years, 2 decades, with all our web service and so on, the email address and sometimes even telephone number, which is not get via POSIX API by the same token, it's being used as the identifier for login of this user into our website, our services, and so on. So some new apps came along. They have got all those requests and requirements as to the base via which we can get this in standard systemic approach. It's non-existent. And so they have to migrate from using this system API to something of their own, to invent their own bicycles or wheels, so to put it, to invent their own security systems and so on. Apart from that, we have got lots of other problems because it has been around for 40 years, for 20 years, whatever. We have been dealing not just with only the development of the projects, but it's about the generations of software engineers dealing with those projects, and maybe those who are not engaged in that, because as to contemporary students, they are pursuing the financial lucrative projects. They want to earn money fast, but not to consider something which is non-existent before it's broken, so to put it. I've got such a classical joke. I say I'm engaged in those things you don't know about before they break. Like your printer is out of order, and suddenly you get to know that there are special protocols for interacting with those printers, protocols for authentication if your files are not saved in the network disks, and you should know which protocols should be used, and some rights should be there. So I'm the guy who is engaged in something which is not existing before it's broken. So lots of people don't want to be engaged in something which is not existing. It's not politically charged or whatever. Not everything is so fashionable out of the old things. So it's quite normal situation. People burn out, they shift focus of their interest, projects are disrupted, projects subside. They are not anymore around, and oftentimes it's those projects everybody is relying and nobody is relying at the same time. Everybody is relying on that, but no one is there who is willing to support it. It was a situation with OpenSL. Everybody is using it. No one is willing to support it. There's no money and so on. Similar situation with the POSIX API of systemic level. It is around, but it's almost as it's not, because who is doing that? Who is supporting it? Maybe distributors, the developers of distributors. 10 years back from now, Red Hat tried to deal with this problem by creating SSD project. SSSD is System Services something daemon. Actually, the first three, these are the four letters of the those who founded them. Siemens, Sumit, someone else also, his name started from S, and D. Dmitry, SSSD, 4 guys who created that. It was all about the fact to create a standalone daemon launched at customer, at client's machine, encapsulates all the work on obtaining information from the sources, authentication, authorization of users, and it has got rather easy client, that NSS module or PAM module, which is uploaded in any app whatsoever. It's very primitive. and straightforward. You can audit the code, prove that there are no bugs and problems there, and it communicates by Unix domain socket to the major daemon, so it could be isolated very easily. You can verify it, mindful of the availability of resources of the one who is turning to it over a decade of its development. SSSD as a project started supporting many different things, and presently it enables us to use SSD ISO Linux policies and multi-factor authentication via Kerber and via smart card, IAPA, Active Directory, and other services as well. Many other things are added up. There are experiments to add it up, the authentication in relation to cloud environments, and Fedora in Red Hat Enterprise Linux version 6.7. SSSD is the major standard vehicle to get information about user groups, authentication of those user groups, centralized delivery of all the setups and apps for those user groups. That way we managed to simplify drastically the configuration of those systems. Even RHEL 7, there was SSSD and NSS panel lab as modules, and on top of that some extra modules, Pancare B5 were present, and PAM PKCIs for some of the modules. The one which was released in May, we concentrated on one branch only. Via SSSD, we work with everything else. NSS, panel app component is marked as the one which will be deleted in the next major releases, because all its functionality is already present in SSSD. This is one of those cases when industrial distributive Red Hat Enterprise Linux is even more extreme than the public Fedora, which conventionally and traditionally is on the front line attacking most topical tasks. But in Fedora, there are guys who want to do it, and they decided to use this PIM case 11 and other components, PAM PKCS 11 and so on. The support and simplicity of the use is very attractive, so the decision was made to consolidate it all. And it's common knowledge that this is only that side of the matter which enables us to work on it, but someone should set it attuned. Recently in Red Hat system, CentOS, the major configuration and the major operator was utility called authcomplete.
And really from 1999 it has been used that is not a utility on the second Python that ceases its existence. Officially, upstream would not support it from January 2020. There was a question, should we rewrite it to the third Python, or should something else be done? And one of the challenges was that actually this code is a treasury of knowledge as to how these things are interrelated, how they should be configured. That is not a trivial thing. Any code is a treasury of knowledge, but in certain cases the behavior of the treasury of knowledge was not quite simple. You have a code which is mixed up, and if we add something here and something will stop operating here, in case of config, such things were quite numerous. There was a fundamental problem. It couldn't maintain the current status of configuration. It was just changing the files. They were written, everything was operating, but it was not written in what status we are. So to restore that status, these files have to be restored. Once again, one of the examples of this bug from Red Hat. This is procedure 142.3480. A person doesn't even start the script starts of config of deletion of the package of config disable fingerprint date. So the model checking the fingerprints, we delete that model and it starts prohibit me and upgrade. Prohibit me and upgrade. All the methods are also deleted from configuration and we cannot log in the system. So you have just broken yourself, and these absolute things lead to a difficult situation, and as a result, it was decided to rewrite that authconfig totally. The authors of authconfig said that I'm sick and tired during these 20 years to have that burden. I'm not Sisyphus, and that's all. I would like to do something else. Such things also happen. Another Sisyphean was found who revised everything, decided, let us produce a utility that will have predetermined configuration profiles, and it will not rewrite anything. It would sublink the profiles or generate files. It will have such a status that can be filled, and thus we can say, okay, we support 1, 2, 3, these 3 configurations, and inside configuration there is a set of options that can be added, but this gives us certain stability and the possibility of testing clear configurations and understand what we are doing, and it is easy to determine if we are beyond these framework of configuration, whether we support it or not, or what should be done with the things that we do not support. The most surprising part for the developers and for the maintenance is that the users are even more inventive than the developers themselves as to how they turn everything upside down, then come and say that you have spoiled it. Auth-select was introduced to Fedora 1 or 1.5 years ago. There were several standard problems when you know that everything has been done, everything is operating, and all the cases were covered, and then a person comes and gives a simple example of which everyone has forgotten. There were many cases like that, and finally auth-select now covers the basic configuration in Fedora. It is recommended to work through SSSD when SSSD would not operate Samba components when bind. For those cases when such operation through LDAP directly is not needed, and most likely the system is of high production computation clusters. We know the statistic distribution of the users. There is the lower part, and that lower part as a protocol has been outdated. NIS Plus was 93, or the NIS Plus is 87, 88. It is lightweighted in terms of establishing connections and time spent for each operation. Some select describes these basic configuration, then symlink does it, but it doesn't adjust or tune the system. It implies that SSSD or Samba or NIS or others should do something else, should build something else. It performs one task well enough, but to adjust it, tune it, we have some other facilities for FreeIPA. We have an IP client installed for working with FreeIPA at a higher level with Active Directory or with Samba. We have RHEL joined to this utility, and finally there is a whole set of system rules, principles that make it possible to automatically tune everything to what we know about the specific medium. All these utilities don't know where we have what are the specific servers that should be used by a specific customer user. This is a task of the adjuster. Role enable, IP installers, and so on. All config per se is rejected, but there is a case that is called old config that maintains the most common options of old config, but it is realized within of select. Thus, the available scripts can be started per se, and gradually they will be rewritten. So this is a compatibility up to a certain period of time. I've already said that NIS has been prepared for deprecation, but there are two aspects. First, as regards glibc, they have removed the components of working with Sr.Principal protocol, but they were put into a special library because, I exaggerate that no one needs it now. In fact, works through Sr.Principal. And the components of NIS proper are also marked for deprecations in the next major versions. NIS is accessible to the company, to the user for high-speed computations, mainly for clusters, and NIS server most likely in RHEL 9 or later will be removed. Everything depends on the request. If there are users who really need it, who provide documents, we are going to talk with them, and thus no one will support the code which no one is supporting. It's very expensive. As to the smart cards, the situation was as follows. If you look at the lower part of the slide, it shows the components that interact directly with hardware in certain drivers, specific drivers, then certain standardization. OpenSea appeared, which sort of supports a whole set of devices, PCSCY, which supports a whole set of devices, specific drivers from vendors, and so on. And all this gives a certain basis, and on this basis we tried to build, not we, but in 1994, they tried to build a certain API, for abstraction of the application from the smart cards. But only by about 2010, they managed to build an abstraction in FreeSoft, that is P11 kit system, which actually is used by uses all the system utilities that operate with smart cards. And it represented in single form. There was a question. We have diverse hardware that is addressed in different ways, that has on different buses through USB, for instance, through Bluetooth, through something else, I2C. How should we address it simultaneously? There was a parallel standardization in 2015. There was a decision. The let us just invent a line so that we can address it. RFC 7512 was adopted, and 4 years or 3 years passed afterwards, and we brought to order the entire stack, access to smart card in different applications. And then PLM kit automatically can find everything that is available. If we have URI indicated under RFC 7512 is given, it can just modules to activate access to a smart card. We can use the keys as such, just indicating your URI under PSS11 in certain way. We have only one key present in the system. We will take it by default. If we have a keys to certain identifiers, it can be indicated directly. Similarly, it is possible to use it in Apache about SSL, as far as I understand. In MGX, they have a similar configuration that was needed. As to the Firefox and Chrome, by default, they just download P11 kit, and everything can be seen automatically. If you're a smart card by which you identify to the public authorities, I'm not speaking about Russia because GOST and work with a certifying center here is a different thing as to the other countries of the world where it is more or less standardized. Crypt algorithm that I used are more or less standardized. Everything is present. As a result, you can see that we cover most of the applications where it is this application should be used. An RPG works above that layer. Sometimes it goes through P11 kit. Thus, we can also abstract from the real hardware. There was a project SoftHSM that is a software module of the smart card, and this is software model of smart card can be present on each gadget by default. This means that we can have a medium in which we develop for a smart card, even we don't need, but the development of the application can be done proceeding from the fact that we have got a smart card, and we always have smart cards in a telephone. We have a smart card, emulated smart card that is signed by the keys from the SIM card and so on. In all Linux systems, now we can proceed from the fact that we have IP smart card and some storage area for these smart cards. On the other hand, and this was how we get the users, how we identify them, where can we get the authentication data, and how are we going to use them. Traditionally, in corporate media, particularly in those who are compatible with the ENG directory, we use the system of unified entry on Kerberos protocol. Major work with Kerberos is aiming at making it really uniform for authentication everywhere. The second issue is that Kerberos, during 25 or 30 years, has accumulated a lot of old crypt, and that old crypt, all these algorithms are not state-of-the-art in modern world. They have to be deleted, and we have to increase the reliability of connection, the reliability of using more or less modern crypts. As to such things as Kerberos, it is not so simple to say that we have a new algorithm, let us implement it, because there are a lot of independent implementations that sometimes are not listed missing, so to say, to each other. And in this field, quite active work is done at the beginning of first standardization through ETF, through a group, the so-called Kitten group, which is dealing with methods of standardization of the common authentication of the future. So that is just such an important title. And addition of any new crypto algorithm, a variation of the algorithm in Kerberos means that we have to adopt RFC, which they describe so that there would be exhaustive information, so that is no support, because no one has written RFC introducing new types of encoding. On the other hand, as to the customer, we have to be able to work to solve the tasks which our user needs. One of the tasks is use of containerization everywhere, and in many cases we want the containers per se not to get any access to this authentication information, so that it would not be released, and the right of access to that information would be determined by the external policies, so that it would not go to the applications. On the one hand, we have introduced the method of storage these credentials first in the kernel keyring, and then we understand that keyring in Linux can be put into a separate namespace. We cannot virtualize it so that the applications would address to it. So we remembered that while realizing Kerberos HAMDO, a special model Kerberos credential manager was created, which allows storing these credentials elsewhere and address them under the protocol above Unix domain circuit. And Unix domain circuit is a normal file object which can be normally cut along the namespaces. Thus we can remove the storage outward the container, and as to the application that addresses from the container goes at the level of the kernel, at the level of that side. The daemon that is on the other side is done. Circuit can determine the credentials of this application and decide whether access will be provided or not, in combination with another component that is called the GSS proxy that allows not to give to the applications Kerberos tickets, but to keep them and to make operations on them in a remote way, similar to cryptographic operations with a private key on smart card. These are done by the smart card, not to the application. Thus, we can totally remove the work with these keys from the container. They will be in the specialized subcontainer that will be accessible. That is not only for the containers, and in this case, SSSD realizes the server part of this component. SSSD launched into a separate container will have all the information on the users, the information on credentials in Kerberos.
Таким образом, на самом деле, позволяет сделать интересные штуки.
We can make some interesting things in addition to those that have been mentioned. Together with storage of the keys in the kernel space, there was a different problem as well. If you have 50,000 servers and one user goes to 50,000 servers just to deploy something or to launch something, then, using Kerberos for authentication, one user should request a key to the services of each of the 50,000 machines. So the credentials, should keep 50,000 bit less than 1,000 bytes. So these are 50,000 by 100 bytes. So replaceable kernel memory would not be sufficient. The quotas can be increased, but it is rather difficult to work with it. So the transition to using KCM solves this problem.
KCM resolves this problem. It's stored on the disk. Everything is actually encoded, enciphered. It could be stacked. Client doesn't see it. It's transparent for him. On the other hand, client needs getting to the server, and he has to identify it. Statical setup is one thing. If we want to scale up to distribute the load, we should use definitions via DNS. And there is a wide number of specifications as to how it should be done. We made support in the beginning of DNS the right. We made specification, implemented it elsewhere, then implemented Fedora because Fedora is using FreeIPA behind all the bug, but doesn't provide direct access to it. Only a special Kerberos proxy, which is identified automatically via those DNS array entries. User doesn't have to know which is where. Automatically he gets there and discovers it. There is very big problem with DNS and Kerberos because everything should be unified and operable. In many environments, machine names were not fully qualified, not a full name, just the first name of a machine. It's good if you have got just a few machines in one domain. If you've got lots of domains and machines have got the same number of names and different names, it's misleading. You should canonize it. Let's say machine is called master, example called example test master. Which master are you referring to, speaking briefly? You should canonize that. When we started canonizing all of that, in many people, the environment was broken down if it was no canonicalization. So it was triple status here. If something doesn't work, you should get to the fallback mode, then it will use full. First full canonization, then brief one, or the other way around. It's frequently used in containers, in OpenShift, for example. We try to finalize the other things as well. As to crypto modernization, from my ticker we removed one DS and triple DS. Life of those crypto algorithms in contemporary times is over. It's history now, as cryptos for passwords, keys, and so on. And it's not yet deleted, but it will. It's ARC4, RC4 used in Active Directory in Samba and so on. But the work goes along with those projects on transition from the use of those methods of authentication which are applied by RC4 to a more contemporary one. Another thing, another side of the matter is Kerberos was created for us to be able to work in malware environment, in open internet. But one of the mechanisms, as in Kerberos protocol, password is never handed over between client and KDC. Both sides know it, but they find some common ground so that they can cross-identify each other simultaneously. And the mechanism was used, the mechanism of protection of security of this password, which was based on timestamp on some computed mechanism in the current time. That way it was possible to deceive in certain locations and try to intercept the password. It's in the middle, it's not interceptable, but some of the digitation could be substituted. In 2010, there was a special mechanism which came up at identification point. It's called SPEAK. It removes all those problems problems. By default, it was implemented. In the beginning, it was just, there was specification or C and so on. And if we prohibit the use of this crypto time cutoff in such an environment. There will be no downgrade. This thing mathematically it's being proven that it's unhackable, it's unbreakable at the current condition of our knowledge. But most important is that SPACE allows us within one and the same mechanism to transmit, to pass on many elements for authentication. We can implement supportive tokens, multi-factor authentication with different factors. We work on it. UTF tokens support in Kerberos will be based on that. As the result, the authentication and authorization in Apache were replaced. A wide number of modules for fresh versions. We don't have an SS mode now, and we don't have this mod NSS curve. It's mode auth GSS API, which is more contemporary and much better. And we officially admitted that a mod and GSS is not potentially possible for the transition of all of that on that. And I mean, it's not just NSS crypto libraries at Mozilla. So here is the situation. On the other hand, at the level of service LDAP per se, Red Hat Enterprise Linux, we removed Open LDAP server because to work with upstream Open LDAP is rather challenging. It's because it's a very toxic community. But per se, they proactively support their own Open LDAP server. When Red Hat announced that there will be no LDAP servers in LDAP, in the version of LDAP, there was a lot of noise around it. But then it turned out that in those companies, about 3/3 of all their commercial users, they launch Open LDAP at on RHEL. So they ended up with a huge number of orders for support. So those guys are thriving. They can support the users because they have got expertise, not to pass it on to someone else. At Fedora, PWuid server is still there. It's retained for us. It's partnership relationships, and by the same token, we're very glad because those partners are promoting and developing infrastructure. In Fedora, we developed Samba AD, and at Red Hat Enterprise Linux, it's not ready yet, as we think. In Fedora, actually, we revise 380 DS server directory management, which behind Red Hat directory server and behind the back of FreeIPA is standing. So it's a new UI in management in integrated way. This is a joint work between Red Hat and SUSE, because SUSE, by the same token, has been using 380 DS most proactively. FreeIPA and Fedora, it's 4.8.0 or 4.8.1 actually by now. It supports a wide number of different new things, and I don't have time to tell you about them. But we have utilities of discovery of typical problems and bugs in FreeIPA setups. They cover about 100 different cases. It does not debug yet, but can do troubleshooting, which is good as well. So you know which way to look, sometimes more important than to debug it. We had very project work on Sensible integration. Ansible free API modules, they can do a lot different, very sophisticated topologies they describe. It's possible to work with Kerberos and so on, which was not there previously. Unlike Fedora, in Red Hat Enterprise Linux 8, FreeIPA is hidden in a separate module. It's a separate concept, a new concept. In Fedora, the module enables us to isolate dependencies between the apps, and also it allows us in a very good and straightforward way to describe what we want to present as the profile of those setups. Those are stream profiles describing typical configurations. You can try it not just at Red Hat Linux Enterprise 8 and CentOS, and it's available as to Samba. Last thing to mention, Samba 4.11 was released a couple of weeks ago. By default, SNB1 protocol is prohibited. Many home NAS using that will stop working with this SMBI, but life is such that they stopped working with Windows because Microsoft disconnected SMB1 3 years ago. They have got some telemetric limitations. When they see SMB1 system, they leave this user, but by default the customer wants to use SMB2 and SMB3, so SMBY is disabled by default. When we extend POSIX at SMB3 protocol, when we're advanced enough, I hope that will happen next year, we'll fully disable SMB1. It's history now, its time is over. That will resolve the problem with NTLM, which could be hacked and broken quite easily. There will be no those backrolls. In 4.12, my colleague Andres Schneier a couple of days ago mentioned that in 4.12 for some of the task problems with encrypted data, Samba is at least 50-fold more rapid than it is now. I'm more conservative. It's by one order rapider now vis-a-vis what he'd shown in May last year, and altogether it's all together with the encrypted flux. We have got a very good progress. And now we have been working on support of a broad number of different stacks and extensions introduced by Microsoft this summer. After another, my colleague Isaac Bucris troubleshooted the security problem with Microsoft. So that's it. Thank you.
I
think we have about 8 minutes. Yes. Well, have we got any questions from the floor?
Do we have any questions? Yeah, we have.
Здравствуйте, расскажите, пожалуйста,
Hello.
про обновление. У всех есть legacy конфигурации.
We all have got legacy configurations we have to support, and how much will it cost to update? What can we encounter as developers who deploy, let's say, 100 of old configurations? And what does he take into account? Which headaches are coming up, actually? What will they encounter as red flags and different problems and hazards, so to put it? Thank you very much for your question. If Ansible is used, it's good. If you use standardized roles of Ansible, it's also good, because most of those roles have got very good variants for RHEL 8 as well. But if you use Ansible only in order to launch external utility, you'll have to rewrite it. For the existing systems which are already implemented, there are utilities of their migration. But if we deploy Ansible, we don't even need that. But nonetheless, to transport RHEL 7 to RHEL 8, there is a utility which is called lib to discover typical problems. If there are not, it migrates distributive to distributive. And there are system rows are a parallel project of Ansible. It uses Ansible as the method of migration and delivery, but it describes more standard roles from the standpoint of distribution, installment of different servers, the complex, the sets of apps, and the migrations as well. But bottom line is that if Ansible is used in a good and handy way, and we have been using the methods of high level in Ansible, like install me this thing, but not launch YAML directly. So it has got different options for RHEL to have, so it will be possible to do it automatically. Configuration files actually could shift, but we should support them if they deteriorate. I have a question. You mentioned utility for half testing. Is it handy to use them in CI, just to include them into pipeline for integrity tests? Yes, they can work on live server, or they can work on different logos and generate JSON descriptions, or for humans, so it's possible to process them further. And so, after all those developments, is it possible to write the username, like my name, my family name, and I will be able to enter this system of roles, or something else should be done before it will be possible? Do you mean to write in Russian language, or, well, it would be great if users could write down their name and then introduce password or graphic code or fingerprint, or you don't use it, or it's out of box now. Using smart card, it's implementable without username. If this user, if the authentication for this smart card is for several roles, you have to also print out the role. But if it maps just like that, you don't even have to indicate the username, just the password, not the password, but PIN to unlock the smart card. I'm not sure about ATFs and smileys, whether we can send them over as well. There are certain implications and anti-tones related to that as well. On the whole, I think it should work just like that. At least with Russian names, I tried it. Microphone was not used for the question. Will someone write RFC for the state standard for GHOST? I assume that the situation is not altogether hopeless. I will not point the fingers at certain people, but I know that there is the interest to do this work, and this is great altogether.